All right. Thank you, everybody, for coming. Wow, the light right in my face is
Super
great.
bright.
So this is Architecting ASP.NET Core Microservices on AWS. So if this is not the session you wanted to be in,
You're in the wrong place.
you're in the wrong place. My name's Kirk Davis. I'm a specialized solutions architect on the Microsoft platform team. I'm a longtime .NET developer and Microsoft platform developer, technically, I guess, since 1983 when I got a Commodore VIC-20 and it came with Microsoft Basic 1.0, but I don't really program in Basic anymore. And this is Nikki Klein.
I'm Nikki. I'm a technical evangelist at AWS. If you're not familiar with the term, what that means is basically they pay me to play with the cool stuff that they build and then show you how cool it is. It's my job. And I'm a .NET developer. I've been a .NET developer for 5 years. I don't go quite as far back as you, but
I think I have a few years on you.
Just a couple.
So the agenda for today's session is we're going to really quick go through, basically we created a sample application using a .NET Core microservices architecture, and we're going to go through why we chose .NET Core. Probably that's obvious, but it could be .NET Framework, I guess. Sort of our architectural goal for this sample application, an overview of the architecture, by which I mean the services that we use to compose the application, how we did authentication and authorization, how we hooked up distributed tracing and logging, session state in DynamoDB, both session cookies for tracking and optionally session state. The rest of it's up there. So that's what we're going to go through here today.
These are some related sessions. This is kind of a sick joke because 2 out of 3 of these are already passed. But if you are interested in the topic moving forward, there is, I think, 1 session on here that's
or
still
if you
available.
have a time machine.
Thursday?
Either way.
Tomorrow at 11:30, if you're still interested in hearing more about well-architected .NET apps. Don't want to miss that one. Why .NET Core? So .NET Core is definitely the future of .NET. It's modular, it's lightweight, it's cross-platform. I'm running on my Mac right now. It runs in pretty much the full spectrum of AWS services now, like full compute spectrum. And if you already have experience with .NET Framework, then you should slide right into .NET Core really fast. It shouldn't be very hard at all for you to get up to speed. And it's also benchmarks for several of our services. It's faster than Node.js and Java in numerous benchmarks, which is pretty cool. And then if you didn't see my breakout last night, I talked a little bit about .NET history. So this is another reason why we believe that .NET Core is the future of .NET. Originally, when Microsoft was going to release .NET Core, they put out this diagram because.
Oh, whoa. Sorry.
You okay? Bless you.
That was just a cough.
That was a cough. Okay, never mind. Sounded like a sneeze.
It's like a bomb went off, geez.
So originally, when they were going to release .NET Core, they were going to name it .NET Core 5, just to show you that they really saw it as the next step in the evolution of .NET. Of course, you know the story. They named it .NET Core 1, now 2, 2.1, and then 3 is coming. So they didn't end up choosing this name, but I like to show it because it's interesting to see how they thought of it and how we think of it. And then lastly, Werner also likes C#, which is pretty cool. So that's always a good thing.
So some of the considerations we took into when trying to figure out how to build a ASP.NET Core Microservices app, our goal was to deploy something where we didn't have any infrastructure to manage, where none of the services required us to launch servers or, God forbid, have to install operating systems or run IIS and get in and configure things. So we also wanted the services to be able to be reachable from the internet. So we put a web front end on it. So they had to be reachable from the internet, but also be able to talk to each other because we might not want to have private microservices that we don't want reachable from the internet. And we wanted support for both anonymous users and authenticated users, which means we have to have a place for users to be stored. So, and also we didn't want any infrastructure for any of this stuff. And really important for microservices application is logging and request tracing. And fortunately, AWS has services that will do that job for us as well. And then last, we're going to talk about the automated CI/CD pipeline where we don't have to manually deploy code up and provision any kind of infrastructure where it's all just going to happen automatically.
And we're going to see that work today, too.
That's true.
So as with anything that you build, there are many different ways to skin a cat. And with AWS, even if you constrain the requirements to no infrastructure, you still have many different options. So today we're going to talk about some of the choices that we made, but you might make different ones, and that's totally okay. Just you can see here, if you go with the no infrastructure compute, you can choose between Lambda or Fargate, storage, S3 or Dynamo. So don't feel that you have to make the same choices that we made, because there's a lot of different options, and the beauty about AWS is that there's an infinite amount of choices that you can make.
And you could mix and match different choices too. I mean, you don't have to just, we chose containers, but you could also do a hybrid application. So you could mix and match on a lot of these. So for the architecture that we chose, this diagram we're going to build up over the next few slides. The computer on the left there represents users that are running in a browser. They're hitting their request to go to an application load balancer. The microservices themselves are each in their own containers. So the blue, orangish, and purple containers are 3 different microservices for products, orders, and shopping cart. The green is supposed to represent perhaps another service that we don't want to be reachable from the internet, so there's no line going to it from the application load balancer. And then DynamoDB is off there on the right, and that's where we're storing everything for this little sample application. For real-world apps, maybe you might want to have some relational database. So there's Aurora serverless. You could actually have a serverless relational database if you had data that was more amenable to that. So if you look at this, though, right now, it looks a little lopsided. Everything's up top, and that's because all those containers are running in one availability zone. And so if a giant asteroid or something took out that availability zone, or a flood, maybe more realistically, then your app would go down. And one of our constraints was we wanted this whole thing to be highly available, so no single point of failure. And so we just set up the container ECS services to automatically deploy to 2 availability zones. So there's 2 copies of every one of those containers. And then for users that, if we're going to have any real-world website that is relying on microservices in the back end, you're going to have some way to authenticate those people. We chose Cognito because, again, no infrastructure to manage. It's a great, highly available service. The AWS Amplify JavaScript libraries made it really easy to take the user's credentials that they enter on the web page, transmit it over HTTPS to Cognito, where the actual authentication happens, and then a cryptographically signed JSON web token, which is a JOT, or called JOT, comes back, and then that gets passed along on subsequent requests to any of the APIs that we want to restrict to authenticated users. In order for the backend services, those microservices running in containers, to find each other, we didn't want them to have to go out over the internet and come into the application load balancer again. So we used a service called ECS Service Discovery, which will automatically register. I'll go into, or actually I think Nikki will go into that more a little later. But it also lets those microservices talk to, say, private microservices that aren't accessible via the application load balancer anyway. And then the last part of the architecture overall are 2 services we added, which are Amazon CloudWatch, which CloudWatch logs, where all of our application logs are going to CloudWatch. Again, no infrastructure to manage, highly available service. And some new features have just been added, I think announced 2 days ago or earlier this week, where you can get visualizations and queries out of your logs, so it's even more useful than it was when we first created this slide. And then X-Ray for distributed tracing. And then there's the web front end.
So yeah, that was the back end. The front end is just an Angular app. It's running the latest version of Angular. And I used AWS Amplify. If you're not familiar with AWS Amplify, I highly suggest you check it out. It's one of my favorite AWS services. The reason being is I don't have to know a single thing about AWS to basically create a cloud-hosted application. So I don't have to know what the service names are called, how to use them, nothing. If I just basically know how to use Amplify's CLI tool, I can just do simple things like Amplify add hosting, Amplify add storage, and it will basically set up an entire application hosted for me on the internet, which is excellent. So least amount of information possible. I also think it's really cool. That link there is the docs. It was a little act of rebellion by the Amplify team. They do not have their docs hosted on AWS. They are hosted on GitHub. So it's a really interesting
soon to be
take.
Microsoft GitHub Enterprise 2018
Yeah.
V2, probably.
Anyways, they're on GitHub. If you know any of the JavaScript frameworks, the most popular ones, Angular, React, Vue.js, you should definitely check out Amplify. It also works for React Native. So service routing. So he briefly touched on this. So we have external service routing, and that's going through our ALB, or application load balancer. And when we're using path-based routing, so you can see the paths there. And then internally, we're using ECS service discovery so that the containers can find each other, basically. So if we have private containers, so you could think about maybe like a products service or a payment service maybe that we didn't create here, but maybe you don't want payment being able to be reached out to the internet, but the other containers need to be able to access it. That is the beauty of ECS service discovery. Identity management. So we used Amazon Cognito user pools, and you can actually use Amplify to create your user pool for you by doing amplify add auth, one simple command. Super cool. However, we actually created the user pool in this case. It's a great service for managing identities. You don't have to manage any infrastructure. You can also use federated identities to log in. So you can set this up with Facebook, Amazon, what are the other ones? Google, SAML, OpenID, all of these.
You're all going to use Amazon, right?
Yeah.
Just to be clear.
Probably not, but yeah. So all of our users are stored in Amazon Cognito user pools, which again, as you mentioned, is using the JOT.
Okay, so since we're using Cognito to issue that JWT token, does everyone already know what a JSON Web Token is? JWT, probably, most people. That's issuing this JOT token. So Cognito did the authentication, and then the authorization the authorization piece we're going to do in ASP.NET. So there were different options for doing that, and one option we looked at was like we could use API Gateway, which has integrated Cognito authorization in it, and you can get pretty granular. You can vary the authorization requirement by request type. So I could have a get to my products be allowed, but maybe a post to my products. If you're adding a new product, maybe that would be restricted. On the other hand, that means we'd have to put another layer kind of in front and have another service involved. And then if I have two services that want to talk to each other and I want to proxy the JOT tokens along, it gets more complicated. So we're already using application load balancer. And earlier this year, I don't know, March or April or something, the application load balancer team launched a feature which is integrated Cognito auth for ALB. So then you don't have to have another service. It's already built into the ALB, and that might work for some people's architectures.
Oh, that was July.
Was it July? Okay.
Yeah.
I thought it was earlier than that.
I just remember.
So anyway, that might work for some people, but for us, because I'm a .NET developer for a long time, I like using that authorize attribute and specifying exactly which group that I want people to be in. So that wasn't really granular enough for us. And the last one was you could do this just with a custom authorization handler in C#. And the pros are you can do everything that I want to do. You can be as granular as you want. I can use different groups and put them on different methods or mix and match. So it's very granular. And then the con might be that you need to write some code, but if you're a developer, maybe that's not really a con. And it turns out it's not a lot of code anyway. This is the actual code for the authorization handler. That's pretty much the whole class. It's just missing the namespace line at the top. And all this code, I just pushed it up to my personal GitHub repo just before this started. So I'll give you the link to that at the end. But this is literally the whole class. All it does is it looks to see in your identities that get in the claims that were passed in from the JOT token, which have already been populated by the middleware into the security principal claims. It's just going to see, do you have a claim of type Cognito groups, and is the value equal to whatever group that I'm looking for? And if so, you're in, and if not, fail. And then you get a denied, access denied. And then you just have to register that in startup. The first part of this is only if you have specific roles that you want to have. Like most production apps, you don't just have authenticated or not. You probably have people who are admins and people who are in some other role, and then unauthenticated users. So you would only need to do the top part if you have different roles. Otherwise, you just add that. You still need to do services.add singleton and register that one Cognito group authorization handler that we just showed a second ago. So that's it. And then for those of you who aren't .NET developers, you might not recognize what this is, but it's an ASP.NET MVC controller method. And in this case, it's a very basic demo of a post for a product. And you'll see the authorize has policy name insight admin group. So that way, if anybody's JALT token doesn't have the Cognito group site admin site admin group, then they wouldn't be able to hit this method. So it's very similar to what I was doing 8 years ago on an ASP.NET Framework app, to be honest. And then distributed tracing.
So obviously, usually the first question people ask when they start building microservices is, how am I going to be able to track all of this, log and something, or find an error when something happens? And so we used X-Ray, which I think is an excellent service. It's distributed tracing, so you can either run it on the host or you can run it as a sidecar. We're using a sidecar. We're running basically the X-Ray daemon in a sidecar container. The reason for that being is we don't actually have access to our host because we chose to use Fargate. So it's abstracted away from us. We don't have access to the host. So we're just using a sidecar container to run the X-Ray daemon in. And it's really cool because you can see basically your entire service and all the interdependencies between the different containers and how it's working. And so we have a little picture for you. I don't know if you'll be able to see it that well, maybe, but you can kind of see how things are interacting with each other. X-Ray has a number of other features if you haven't checked it out before, besides this service map visualization. Obviously, if there's an error, you'll get the whole stack trace, which is pretty cool. So if you haven't looked at X-Ray, I highly encourage you to check it out after this presentation. But this is just one of the many features you would get with X-Ray's distributed tracing. And then logging. Logging is important. We need to log everything, and we want to consolidate our logs. So we used CloudWatch logs, and our CI/CD pipeline spits out logs to CloudWatch. Our container logs also go to CloudWatch. And then for our application level logs, we just installed that NuGet package, AWS logger.ASP.NET Core, and then the application will log, and it will also spit out to CloudWatch. So we now have them all in one place, and from there, you can do a bunch of things in CloudWatch, as you mentioned, like analyze it, create dashboards, all kinds of fun stuff.
And the logs were really important, like even in developing this sample app, like Microsoft at one point changed the name of the container for ASP.NET Core, and it's now like dash SDK or runtime, whatever, when they went to 2.1, and I had changed something, and anyway, just being able to have access to the logs to see what happened just makes it really quick, and you go, oh, okay, because all the logs are going to one place. Does anyone not know what Fargate is already? I just thought about that we've been talking about Fargate. Would anyone like me to tell what Fargate is? Yeah? Okay, why not? So Fargate is a feature of ECS, which is a container orchestration service, where you don't have to worry about the Docker host. You don't even see it. The underlying host is not even in your VPC. You just push up your containers. We will automatically place your containers, scale them up and down according to whatever rules you set, make them highly available across whatever availability zones that you set, and then you're just paying per second or per minute or something like that. You're paying for how long the container actually runs. So the pricing is sort of similar to Lambda, rather
Serverless
than
containers.
Yeah. So instead of paying for the underlying host, you're just paying for that container to run.
It's just a launch type, so if you're in ECS, you can choose to either launch your containers on EC2, which means you're managing everything, or you can choose Fargate, which means you're managing close to nothing.
Almost
which
nothing.
We
really.
like
it's
managing
like serverless
nothing.
containers.
So.
One caveat being that currently Fargate only supports Linux containers, so that's .NET Core only, not .NET Framework. But I assume everyone's probably, if you're a .NET developer, you've seen the writing on the wall, and you probably know that you should be doing new projects in .NET Core anyway, really. So I'll try to stop coughing, sorry. The air here is so dry. So I was going to talk a little bit about session in ASP.NET Core. So with a microservices application, you might not even need to track session with session cookies. Oh, I have one that's already open, but
okay.
I'll drink this one too. So if you have a microservices app, you might not need to track session state, especially if it's like a microservices app that's running for back-end stuff that's not exposed to the internet as a website, then you wouldn't need to worry about it anyway. But it can be useful for tracking unauthenticated users. If you've got people visiting your site and you want to be able to track them from request to request, that's really useful. Or if you're using the out-of-the-box ASP.NET, the local accounts checkbox in Visual Studio, if you're creating it that way, or if you're using the OpenID Connect authentication. The authentication ticket is stored in session cookies, so it can be very useful to do this. The cookies are ASP.NET by default, ASP.NET Core, the session middleware, it encrypts all of its session cookies so that they can't be hijacked or impersonated or forged or whatever. So it encrypts the cookie with encryption keys, and when it starts up, by default, if you haven't done any other configuration, those encryption keys are going to be generated and stored locally, which brings us to an issue where if you have a distributed application like this, I have, say, some microservice running in container green, whatever at the top. You can see each container has its own keys. And so if the first container issues a cookie, then the next request that browser makes, it's going to send the cookie. It might go to a completely different container, either a different microservice or even the same one running in a different container. But that other container doesn't have those encryption keys, so it wouldn't be able to decrypt them. And so it's going to create a new session cookie. And so you just have this endless new sessions being created. None of them would be shared, and it would be broken, as I discovered when I did this in Lambda at one point, like when .NET Core first came out for Lambda. So the solution is to take those encryption keys and persist them somewhere in a shared storage place. You're going to want to do that, you do an implementation of the IXML repository interface. And this is, you could save them in DynamoDB. There's other services you can save them in. I found, well, actually, I'll talk about this in a second. Yeah, so some of the services we have where you could potentially store these would be Secrets Manager, Parameter Store, DynamoDB, S3. Nikki's going to show you some code in here in a second. I did want to say that for Parameter Store, I just, like 30 minutes ago, happened to bump into one of the developer, SDE, software development engineers, who puts out our NuGet packages. And they've actually come out with virtually the same code that we're going to show you. It'll be available as a NuGet package eventually, and it's already available on the AWS GitHub site. So you don't have to take a picture of this one and use it if you don't want. We'll have the official one that's coming.
So this is our class that we used to store our cookie encryption keys in Parameter Store. Initially, we chose Parameter Store because it's free and it's serverless and it's a feature of AWS Systems Manager. But then we thought about it and we were like, well, because it's free, we don't know how much traffic we can actually be sending to it. And so we actually changed our minds and decided to store the cookie encryption keys in Dynamo. This class is not very complicated. It really has two methods, get all elements and store element. And the class that we're going to show you that we ended up going with, it has the same two methods. The difference being it's actually calling the DynamoDB SDK.
Oops, sorry.
Did you skip over it?
Yeah,
so this is the Dynamo.
That was Parameter Store, and
Go over
this
one.
is Dynamo.
This is the DynamoDB version of it. So it looks almost the same methods. It's using the DynamoDB object persistence model to actually store the cookie encryption keys. And then the XML key class is just a simple POCO. There's nothing complicated about it. The attributes there are, you can see the little attributes on top of the class and on top of the properties. They're just part of the object persistence model. So they just tell the class where it's going to store the keys.
So if you were, say, migrating an existing ASP.NET application over to breaking it up into microservices, moving it in, if it's like every other ASP.NET app I have ever seen, probably, the developers used a lot of sticking arbitrary data in session and then reading it out later. Might not be the very best practice, but in a lot of cases, for a quick solution, that's what developers do. And again, for microservices, you may not need to store anything in session. Browsers have local storage that you can use to stick things in with JavaScript in the browser. But if you do need to store things in session and then have that be available to your all of your microservices, out of the box, ASP.NET session stores it in process, right? If you were an ASP.NET framework developer, you probably know that you could go into web config and change it from in process to like SQL Server or a state server. With ASP.NET Core, the default is also in memory or in process. And then if you want to put it somewhere else, you have an implementation of iDistributed cache. So Microsoft has provided iDistributed cache implementations for SQL Server, surprise, surprise, and Redis. Both of those solutions would require you to have yet another set of EC2 instances, servers to manage, and SQL Server to patch, and they're not, that's infrastructure. And for us, we wanted the least amount of infrastructure, or ideally no infrastructure. And so we're already using DynamoDB to store other stuff, including those encryption keys. So we thought that would be a perfect place to store session state. And there is a NuGet package that we already have for ASP.NET Framework that will do this for you. But for ASP.NET Core, we haven't published that yet, so I just wrote my own. It was pretty simple to do. Rather than having to then, if you're using SQL Server, for instance, every time you get something out of session, you're supposed to be checking whether it's expired. If it is, you have to make another call to the database, delete it. But DynamoDB has a TTL feature, so you can have things automatically expire and be removed without having to make an extra call. So at the end of all that, the code was really simple. This is one method in the code, which is just the get async. In order to implement iDistributed cache, you have to implement both synchronous and asynchronous get, set, remove, and refresh methods. So we just did them all as async, and then for the synchronous methods, we just called the async and then did a dot result or dot wait to make it synchronous. And then the actual session data is passed in from the session middleware as a byte array that you can see as the return type there. It's task of byte because this is asynchronous, but it's just returning a byte array, which has a base 64 encoded bag of your session data, which is just key value pairs, right? Or if it's if the value was some object that was serialized, it'll be the JSON serialized version of that. So the actual DynamoDB record just has the session ID, which is the primary key, the session, which is that byte array, and then I have the expiry type also in there, and then when it's supposed to expire. So we were going to just show you a quick demo of the sample front end. It's not a production ready. We have sample icons and so on. Let's see if PC2, no. There we go. Oh, what you're extending maybe?
Oh no.
Give us a second. And there's a giant mountain that looks familiar to anyone who has a Mac, probably.
All right.
So I'm actually on a Windows. I have Windows 10 ThinkPad, but just to prove that two people can collaborate, we were each writing code. She's on a Mac, I'm on Windows, and it all just worked perfectly with .NET Core, which is awesome.
So this is our application. This is a shopping cart. There's two things in it by default, just because we threw two things in there to show that. You can add things to the cart, so I'm not logged in right now, so I can just add this deep lens to the cart. Sorry, there's no user feedback. I didn't get to that.
I just added the Amazon Deep Racer card because that looks really cool. I don't know if anybody saw that demo this morning.
I really want one. I really want one really badly. Anyway, so this is I added something to my cart. I can remove something from my cart. I'm all unauthenticated at the minute. I can log in. Now this is using AWS Amplify to actually communicate with Amazon Cognito.
And there was very little code that I saw she had to write to implement this because the Amplify library does so much stuff for you.
So now I'm logged in. I can add things to my cart again. I can do a bunch of things, but basically it's a very simple app. If I look at the API, so this is the products API, so I have it up here. I think I can hit the cart one. Show you guys what's in my cart. So this is the default cart, right? So this is an unauthenticated user would be hitting this API. You can hit this URL from your phones right now, and it would produce the same thing.
Go for it. We're highly available. Hit refresh here once. I just want to see if we'll pull the, there we go. So.
Oh yeah, you can add products. I'm an admin.
Yeah, so she's an admin, and she's got her email up there. Please don't spam her. Or spam her. Maybe, I don't know. So.
Thank you. Nobody was going to see that until you specifically called it out.
Right there. It's Nick Kick at, okay, I didn't say that.
Appreciate that. Great.
She's authenticated now, so she can add a product.
I can add a product. I can delete a product. These little delete icons showed up. I don't know why that
Did you add a product? Yeah, go ahead.
You want me to add a product?
Yeah, we have 30 minutes.
What should we add?
Anybody have a product they want to add?
You already added the
Anyone.
deep race car. Like, What?
Lewis, let's add Lewis. He looks expensive.
How much is Lewis? $1. It's really sad for Lewis.
That would be expensive for my 5-year-old.
There's only one of him, so.
Yeah, that's true. You're going to go out of stock really quick, Lewis.
Actually, it's just that. Cool stuff. Is he cool stuff?
I saw that. I think he's cool stuff. Is anybody going to buy him? Go in your phones really quick and buy Lewis. Okay.
There he is.
All right. So that was a demo of the front end, and then we're going to do another demo a little bit later after we tell you what we're going to demo later. So for organizing the code for this sample project, we just had 3 microservices plus the front end. We wanted to set it up in such a way that like anytime you make a change to the code, I can just do git push, git commit, git push, and it would just magically go deploy it and everywhere, whether it's the front end or the containers, whichever microservice it was. We were also trying to think of ways where you could organize the different repos or the different projects or the microservices so that if you theoretically had a team that was working on one of them that was really fast and the other microservice was maybe evolving at a slower velocity for whatever reason, they could be deployed independently. Just because I make a change to the cart service doesn't mean I want to have to redeploy the product service. But at the same time, I want to be able to see them all in Visual Studio. So like, there's no single way to do that. There's a lot of different ways, and I'm open to hearing what other people have done. We chose to have like a solution file that's in one repository, and then, sorry, each microservice is its own CS project in its own folder, which is its own Git repository, so that every one of those can be independently done. And then if you had an actual production app, and I know I ran into this at a previous job where we had many microservices, and so some teams were only really needed to like see these 8, and another team might need to see these 6, including 2 of that 8. And so we had like 6 different solution files that we kept in one repo, and then I would, like if I was on some particular team, I would open up a particular solution file that would show me the 6 microservices that I cared about. So that was something I've done in the past. So we kind of did similar here, but we only have one solution file. There's only 2 of us, so it wasn't really a big problem. So the total number of Git repos that we have is the total number of microservices plus 1 for the solution file and any other things that we want to dump in the solution folder, like a copy of documentation or something like that. So this is what it looks like in Visual Studio.
Oh, we need to switch back to the slides.
Oh, can you guys not see that?
How long was that happening for? It was a while.
Yeah, sorry. There we go. Now it makes a lot more sense. There's multiple ways to solve that.
Apologies, that was my fault.
Yeah, it was your fault.
Yeah, it was.
So you could put everything in a single repo. You could do some kind of conditional build, but there's more work involved, and I was trying to do the least amount of technical work as possible. So in Visual Studio, that's what that looks like. On the left, for people over there, sorry. On the left, you can see the Visual Studio solution view where there's the cart service, order service, product service, and then the front end, the static website, which she mentioned is hosted in S3. The other 3 all go to containers. They get containerized and pushed up. And you could actually publish these from Visual Studio with the AWS toolkit if you wanted to do it into a dev environment. But for your production environment, obviously, you don't want that. And then the actual folders, I think I clicked into the solution folder so you can see it's basically just a solution file and some other detritus that accumulated in there. And then for the CI/CD pipeline, we actually have 4 different pipelines. Each pipeline is triggered by a change to the source code in that associated repo. So when we took these, are you supposed to be talking right now?
You know, nobody would have known that if you didn't just ask me that
You're
question.
going to do the demo anyway. So when we did the screenshots for this, originally we had the static website being served out of a container, and then Nikki cleverly said, why don't we just stick it in S3? And so we did that. And then they actually, because AWS is so often sort of iterating and improving stuff, the reason that last one has a different style is because they've rolled out a whole new UI for code pipeline. So it looks kind of nicer now.
And that one's obviously shorter because it has less distance to go. There's no build, it's just static files.
The first 3, you can see the ones that go to containers, there's a source, so that gets triggered as soon as it detects that the source code has changed in the Git repository. And we're using the internal AWS provided Git repository called code commit. You could also use GitHub that's already integrated into this, so you could just tell it to use GitHub instead of code commit. Then the next step for all three of those containerized microservices is the build step. That's using code build, where it just creates a Linux container to run your build. The Docker file itself, we're using that multi-step build where it does the build in one container, and then it uses just the runtime container to publish into, so you have a smaller container image. And then the last step is the deploy. There's a lot of different mechanisms for deployment that Code Pipeline supports. We chose the built-in integrated deploy to ECS, the ECS deployment provider, because it'll just deploy right to ECS, including Fargate.
The other reason to also have a multi-stage Docker file is for security reasons. You don't want to take your source code with you to your final container.
That's true. Okay, then Nikki's going to do a quick demo of making some arbitrary change.
All
I
right.
think we're going to add a controller method. Maybe it should be like, hey, Lewis, I don't know, since we're picking on Lewis today.
All right, so I'm going to open the products controller. Let's make this bigger.
If only that Mac had a nice maximize button.
I'm going to ignore that. All right, I'm just going to make a get call. We're all cool with that. How about that? I'm going to do something simple like say hi to all of you. Get hello message. How about that? Whoa, typing too fast. Hello from reInvent, if I can type.
The audience will check your spelling.
I know they will. All right, it's pretty simple, but it's for the purposes of this demonstration. All I have to do is actually do git add, commit, push, and then it will be live, and we'll actually be able to see it in the console, going through the CI/CD pipeline, and then in the browser when it's done.
Note that best practice is not making a change and immediately pushing it without building and running it locally, but
This is so simple,
in
though.
the
Like
interest of time.
you want me to test this?
No, I'm fine. I'm sure it'll work.
I know it'll work because it's so
doing a
simple. It's all
wetware.
it's doing is returning a message.
I'm doing wetware static analysis on it right now. Looks good.
Oh, you know what I have to do? I have to delete my keychain for code commit because it saves my Git credentials. Something
Mac
I really
again, jeez.
don't really like about code commit, which is why I use GitHub.
I never have to do that.
Yeah. Did you update this?
The products controller, I hope, possibly.
I'm gonna pull something down. What did you do?
The best kind of demo. I don't remember.
All right, let's try that one again. I'm just gonna look at you. Don't remember? This would have happened in the last like 24 hours.
Because I saw that I had a change that it said I was 2 commits ahead, and so I couldn't remember what I did, so I just did a push.
Great,
This is
excellent.
a sample app, by the way. None of this would go into our production code.
Good job, Kirk.
Okay, so you already did the push, right?
I did the push.
Okay, so
and now
if we
by
go
the
to
time
code
I log
pipeline,
in,
do not try to hack into my account, please.
I don't think they
No,
can.
not you. I meant everybody else.
I was like, please,
Okay,
I have
so-
complete access.
Code pipeline. Okay, finally, which one? Product service.
It
There
was
we go.
that one.
So that's already, so they missed the little spinning wheel on the source one because it took a while to get that Mac keychain thing working. But
Yeah,
then
okay. You want to blame me? I had to pull down some crap.
the code, so you can see the code build is going just now, the actual build kicked off. That actually takes about 5 minutes to kick off. So I thought, wow, we have 20 minutes left actually?
We just can
Yeah,
ask questions
I think
while this is going, and
while
then
that's
we'll
happening,
see it
do
live.
people have questions about what we sort of went through? That was much slower when we tried doing this rehearsal over the phone at one point.
He lives
yeah.
in Portland, I live in Seattle, so.
Yeah, let's do that. Great question. The Docker file is really close to being the one that if you add Docker support in Visual Studio, I just genericized it a tiny bit. I think. Is this the one I genericized? Yeah, so it doesn't have the project name hard-coded in there. It just says star.csproj, and that way I could basically copy and paste the same one into all of them and just change the entry point down at the end for the DLL. But other than that, this is the same thing you would get if in Visual Studio you right-clicked and said, add item Docker support, or when you create a new project, if you add Docker support and choose Linux containers.
It does some kind of magic though when you do it in Visual Studio. When you add Docker support, it like runs right over me.
No, it doesn't.
Oh, for me, it's some kind of magic is happening when it because the Docker file doesn't look like this. It looks totally different.
It looks almost the same. That's what I'm saying. But they have hard-coded the project name in, which I didn't like.
Oh.
But I mean, I've done it both ways.
You mean at the bottom?
No, yeah, something. Anyway, is the code pipeline? Probably not yet, but it should be almost done. Oh no, about three and a half more minutes. I just saw an announcement like yesterday morning, I guess, that code pipeline is going to be faster now. So I was kind of hoping that we would see that shrink down, but I didn't. I tested it today, and it didn't seem to happen. But another question? So the question was, are we using like Git submodules, or are we just lazily putting each microservices project into its own Git repo and leaving it at that? Can anyone guess the answer to that?
It's definitely the second one.
That's the second one. It's been a long time since I worked with Git submodules. It was actually at that same prior job I had where I was a team lead for a large number of teams, and that's the solution we used there was Git submodules. I didn't really want to go through the effort for this because we only had 3 projects, and originally, so we just have each one in its own repo, but you could use submodules to also like share classes or share code or DLLs. Maybe they'd have to think that through, but that would be a perfectly good alternative way to do this, I think, especially if you had a really big architecture with like 50 microservices or something. So
I'm just playing the build spec YAML. So if you wanted to create this same project in code build, you would have Docker file and you'd have this build spec to tell code build which commands to run before the build, during the build, after the build.
And if you scroll to the bottom, you can see that it's, if you see about the 4th line from the bottom that's yellow, it says printf name, the image
Line
URI,
23.
and then, so there's 2 containers in there. One is the container for the thing that you're building, and the other container is the X-ray daemon container, which is, we have instructions on the documentation for how to like easily create that container. It's just like a couple lines to pull the image down and push it into your own container repository, whether you're using Docker Hub or ECR, which is our container repository. Yep. Yes, we do. That's actually how we generated that graph thing that we saw before.
You want to see it in the console is what you're asking?
Oh yeah, sure. So we configured X-ray, which was, it just shows you that it's only going to be whatever has happened in the last, however long the X-ray traces are going on here, but let's see. So there it's showing some things. The cart service will actually reach out to the product service if you add something to your cart. So that's probably just the gets. Can you, instead of last 5 minutes, can you do like last, I don't know, hour or something? And then, is it
Yeah.
That's interesting. It still doesn't look right.
Oh.
Oh, it was just generating it slowly.
Sorry.
And there, so now you can see from the last hour, so when she added something to her cart, the cart service just talks to the product service. And to do that, it's just an HTTP request to, in this case, the URL that it talks to is product.aws tech summit. And that's because originally I was doing this presentation somewhere else at a tech summit. And so the way, that's using service discovery. So that's how one microservice in our app architecture here can find another one if they're all sharing one namespace. So for this application, I created a namespace called Tech Summit. And then every microservice has a name. So the shopping cart service is just cartservice.techsummit. The product service is productservice.tech, or I think just product.techsummit actually. It doesn't even have product service. We can show you the code actually. Do you want to pull up the cart controller?
I don't have that
There's
pulled
no,
down.
the way that one microservice talks to the other one is via HTTP to a get or post or put request. But the way that that works is Route 53, which is
I
our
know.
DNS resolution service for your VPC, Service Discovery will automatically create a private hosted zone with the base domain name of the namespace that I said, like in this case, it's Tech Summit, and then it will create Route 53 DNS records. In this case, I chose A records for each service that gets created. Like for the product service, it'll create product.techsummit. And then anytime any other
There's your controller.
microservice wants to talk to product.techsummit, the first thing that actually happens under the hood is a DNS resolution request, just like you were doing it from a browser. You know, where is product.techsummit? And then Route 53 knows where all of the product.techsummit containers are. So it's got like, maybe in this case, 2 IP addresses. If you had 50 copies of this container, it would have 50. And Route 53 will then round robin the answers back to spread those requests out among all your different containers. There's also health checks. So if one of your containers goes belly up and dies and a new one gets spawned with a different IP address, Route 53 will stop giving resolution to the first IP address, and instead some of the requests will now resolve to the new container that got put into service behind a load balancer. Sorry, actually as soon as the container is registered. It doesn't have to be behind a load balancer. So that's how these, and if you actually went into your VPC and the same VPC where your containers are running, and just say you launched an EC2 instance running Windows 2016 or something, and you remote desktop onto that thing, and I actually did this just to prove it to myself when Service Discovery launched, and open up a browser, and I type in my browser, http://product.techsummit/API/products, I will get the return from my microservice. So it's actually using DNS under the hood to do service discovery. There's a lot of different ways you could do service discovery. There's third-party and open source products that do it. This is a really easy one, and it's integrated with ECS. So every time ECS places a new copy of that container, it tells Route 53, add this IP address to the list of them for this service, and then Route 53 will round robin them. Did you already show that code? I wasn't even paying
I
attention.
pulled it up
Oh,
on the
okay.
GitHub. I don't have it locally because this
Oh,
is my
right.
new machine.
Okay, so if we scroll to the very bottom,
You drive.
yeah, keep my glasses off because I'm old. So, let me see it. This is the method get product from product service async. Here's how you have to instrument it if you want to get the X-ray tracing for those external HTTP requests. And it literally just makes a call to product, I cannot use a Mac apparently, to product.techsummit, and then it adds the path /API products and then whatever product ID that you're trying to add to your cart. And then it returns, I'm actually logging this success, fetching the product from the product service. And then I return that product. And then I just check whether the stock is enough. And we're never actually decrementing the stock right now, so it never goes down. But it makes inter-service calls between microservices really easy if you have a nice service discovery mechanism like that. Anybody else have questions or suggestions or things like that? We'd like to hear what you guys do as well. How about in the back first? Sure. So right, I get it, and that's a common question. So the question was, choosing between like Fargate or ECS with EC2 launch type, in which case you have to choose the EC2 instance type and set up scaling for the underlying, the host, the Docker hosts, versus Fargate, where you just say, here's my container, please go run it, and there's no infrastructure. Is there a case where you would still want to use ECS with instances? And the answer is yes. Obviously, if you're running ASP.NET Framework and you need a Windows container, you have to use the EC2 instance type at this time. Fargate doesn't currently support that. But even then, if your company, if your dev team maybe has some particular instance type that you want to use for some reason, maybe something that has a GPU, or maybe you want to have more control over it. Maybe you want to run an agent on that host. Maybe you're using New Relic and you want to have some New Relic agent running on the Docker host that's collecting data. Well, if you're using Fargate, you don't have access to the host. You can't see it. It's not in your VPC. We're the ones managing that. So if there is some kind of agent you want to run, you would have to do that. You also get more control over how containers are placed on the underlying host if you're doing that yourself. You could say, try different bin packing strategies. There's a scheduler, open source scheduling, container scheduler library that we put out called Blocks. So you could use that to do very sophisticated scheduling mechanisms of how I want the containers to be placed. I want to try putting 3 of them on this one, but always one of this container on every host maybe. So there are instances if you want that extra control, you would do that. As far as cost, that's you'd have to look at your particular use case and figure out, is paying for it by the second. With Fargate, you pay by the second, and the price is based on 2 indices. One is the virtual CPUs, so the amount of compute power, and the other is based on memory in gigabytes. And they don't scale. It's not like Lambda where they're locked, and if you pick one level, you're going to get that much CPU and that much memory. With each CPU choice that you make with Fargate, you get a range of maybe 4 to 6 different memory choices you could have. So you really have to look at, I could potentially save money by doing it on EC2 if I was very good at packing my containers on there. On the other hand, you've just bought off on managing EC2 instances and setting up your own scaling of the hosts themselves. And we don't patch those instances for you. So if that Docker host, there's a security patch or just some update that needs to be applied, that's then on you. So you're going to eat that administrative burden. Does that make sense? All right. And
it worked.
Oh, yay! Oh, you actually pulled it up. So this is the hello from re:Invent. So it deployed. We didn't have to do anything other than a git push, and by we I mean her. A git push, and then it all just automatically went up. Now, in a real code pipeline, ours has 3 steps: source, build, deploy. Does anyone have an idea of what might be missing in there for a production app? Test, right? So you probably want to have tests running, a test step, and code pipeline fully supports that. But one of the great things about being an SA is none of my code gets tested. So we didn't actually do that. But I used to work in production shops where lots of unit tests get written. And so you could run all your tests in containers as well. You could run Chrome driver if you really want to test your front end and so on. In this case, we were the testers. But that was and then did you have a question?
Yeah, how do you guys support blue-green deployments?
Sure. So actually, Code Deploy just rolled out today support for blue-green deployments to ECS. So you could we use the ECS provider in Code Pipeline directly. Instead of using that for deployment, we could have used Code Deploy for that last step. And Code Deploy can actually do blue-green deployments. It will.
There you go.
Yeah, there you go.
We just had to implement our own.
Yeah, so this just came out today. So
that was yesterday, November 27th.
Or yesterday, sorry. I wish it had been a little earlier for you. Yeah, there's been so many announcements this week. I'm just trying to keep up with everything and make sure that we were not going to be obsoleted. So I know we talked about parameter store and how there's a NuGet package coming out for that that allows you to store that IXML repository, store the encryption keys for your session. You won't have to like copy and paste code from my GitHub repo. You could just use that NuGet package when it comes out. And in the interim, the official AWS Git repo, I'm sure his code's been tested more than mine because mine was me testing it by sticking things in session state and making sure it worked. Can you go to DynamoDB really quick? I kind of wanted to show something. We still have 5 minutes. And the guy who wrote the code. His name's Norm Johansson. He's giving a session that started 10 minutes ago, just down the hall here, where you could catch the last 45 minutes of his when our session's over. Hopefully not everybody gets up and runs right now. No, okay. So he's going to be demonstrating the AWS toolkit and talking about deploying things from within Visual Studio and some other enhancements that are coming out. He's going to be demonstrating that. So if you go to DynamoDB, this is our DynamoDB tables. If we look at the Tech Summit session state, that's actually, I hate you.
Use this side.
Okay. If we go to the items, so we've had multiple different people apparently hitting this somehow. So here's all of their different session cookies. That's partly because I've done it from
I've done it
two
a bunch
different
of
laptops.
times.
Norm Johansson hit it, she's hit it. So
From 3 different laptops.
right, and then as these things get expired, they will come out. Now I'm wondering if the audience has been hitting it, because there's a lot of them in here. So, and then the actual encryption keys are stored here. So over time, those will get the keys will expire, and then the ASP.NET Core session middleware will generate new encryption keys. So over time, we've had 2 of them. I did not encrypt the actual keys. For any production environment, you should encrypt your encryption keys. Probably don't have to explain why that would be really important to not leave your encryption keys in plain text. I only did it here in case I had time to copy and paste that into JSON and show you how the actual key data is in there. And that's all just being passed through. The IXML repository implementation I did doesn't actually do anything to it. It just sticks it as a string into the database. We have 3 minutes left. Did anybody have? Yes.
Would you then just use the key management services to encrypt the key in that case?
Yes, but
Yeah.
you wouldn't have to do it yourself if you don't want. Both DynamoDB and Parameter Store, you can specify that you want it stored encrypted. In fact, DynamoDB is now going to be encrypted by default, I believe. And Parameter Store, it already is, right? I wasn't sure if it was released yet or not. I'm so glad
Yeah,
it was.
it is.
Parameter Store, you can choose to use, instead of as a string, you can choose to store it as secure string and choose which KMS key that you want to use. Do we want to flip back over to show the link to, excusez-moi, show the link to the, that's the GitHub repo. I put it all in one repo because I didn't want to have 4 different repos copied up. So if you want, you can pull code down from there. It's not production code. This is just sample demo code that you can look at and play with. Please don't deploy this to a production app. Yeah, I know. And I also I exported a
We'll
copy
see how
of
far he gets
the
with that one.
slides. Yeah, so these slides will end up on SlideShare in a few days, and then there's a PDF copy. in
Oh,
the
look, you
repo.
already put my email on this slide.
Oh yeah, so both of our emails are there. So, and somebody's Twitter handle. So that's good. Nikki hosts a Twitch show, which is all focused on developer stuff. Actually, a whole bunch of Twitch shows. This whole week, she's been live streaming on Twitch. For those who don't know, Twitch is a part of Amazon also, part of AWS or Amazon? AWS.
AWS bought Twitch.
Yeah, AWS bought Twitch at some point, is what happened. So, yes.
Is it possible to get information to quickly screen the new pipelines and so on? If our team creates a lot of microservices and so on, I don't want to.
Right. You should be able to automate all that with CloudFormation. There's also a publicly accessible tool that we launched sometime this summer called the CDK, the Cloud Development Kit, that will
I told
generate.
him about that one.
You already did?
Oh yeah, I sat next to him on the bus.
Oh, you told him personally. I thought you meant you told the whole crowd.
No,
and I
him.
didn't hear it.
Him personally.
So there's 1 minute till the session's officially over. I have time after that. But you could use the CDK and write it in C# and actually create your stats that way, and it will generate all the CloudFormation, unless your favorite
Try it.
thing is writing incredibly complicated JSON or YAML code as templates. And if that is your favorite thing,
No, it's not.
Congratulations. Was there a hand in the back? Yes.
How do you use Cognito for what? For authentication. You mean
Like
how
what-
is it working?
What specifically would you like to see?
Oh, how I interact with the Cognito. Okay, well, that's actually
Do you
using
mean to,
Amplify.
like create a user pool or the JavaScript that talks to it?
Well, actually, I could just open this up
Okay,
here.
so she's leveraging a JavaScript library that comes with Amplify. If you haven't been to the AWS Amplify website, go to Google or Bing, I guess, and type AWS
So
Amplify.
Amplify is three things. It's a CLI, it's a JavaScript library, and it's pre-built UI components. So you can use any number of the three things. For this application, I'm using the CLI and the JavaScript libraries to hit Cognito. So I'll pull it up.
And when we originally did it, AWS Amplify wasn't yet out, and so we were using the old Cognito JavaScript SDKs and then copying and pasting code from the documentation and then testing it until it worked. And then when Amplify came out, she just ripped all that out and in like 10 minutes got it working with Amplify. So that was definitely the way
Yeah,
to
you
go.
can get it working with Amplify like really fast. Like I literally, he's not kidding. Like it was 10 minutes and it was up and running.
So I wanted to make sure I said thank you before everybody's gone. Thank you for coming to the session today. We really appreciated it.